Hi students, I am Prashant B. Chandran, Assistant Professor, Automobile Engineering Department, SN80 Ador. In this video, I am teaching you to solve a problem on NTU method. This is problem number 2. Let us start the problem. Determine the heating surface area of an economizer in which the hot gas and water are in counterflow for the following data. That is, for gas, T1 is equal to 400 degrees centigrade, m dot h is equal to 210 power 3 kilogram per hour, CPG is equal to 1.045 kilojoule per kilogram degree centigrade. For water, T1 is equal to 100 degrees centigrade, m dot C is equal to 100 into 10 power 3 kilogram per hour, CPW is equal to 4.187 kilojoule per kilogram degree centigrade. Heat transfer from gas to water, Q is equal to 14,000 kilowatt. Overall heat transfer coefficient from gas to water is equal to 85 watt per meter square degree centigrade. Okay, this is the question. It is determine the heating surface area. Surface area is the question of an economizer in which hot gas and water are the fluids. Flow is counterflow, it's given. T1 m dot h, CPG, etc. are given for gas. For water also T1 m dot C, CC heat, etc. are given. Heat transfer is given as 14,000 kilowatt. Overall heat transfer coefficient is given as 85 watt per meter square degree centigrade. Okay. Then first of all, we are writing the given data. What are the data given? That is, I am dividing the board into two. That is hot fluid and cold fluid. Hot fluid here, hot fluid is hot gas and the cold fluid is water. Okay. Also, it is given that it's a counterflow arrangement. Okay. For hot gas, T1 is equal to 400 degrees centigrade given. M dot H is equal to 200 into 10 power 3 kilogram per hour is given. It is equal to 200 into 10 power 3 divided by 3600 kilogram per second. Then CPH is given as 1.045 kilojoule per kilogram degree centigrade. Then cold fluid temperature, inlet temperature is given as 100 degrees centigrade. Mass flow rate of cold fluid is given as, that is m dot C is given as 100 into 10 raised to 3 kilogram per hour. That is 100 into 10 power 3 divided by 3600 kilogram per second. Which is equal to 100 into 10 raised to 3 divided by 3600 kilogram per second. Then CPC is equal to 4.187 kilojoule per kilogram degree centigrade. Q is given as 14,000 kilowatt. Then overall heat transfer coefficient U is given as 85 watt per meter square degree centigrade. Okay. When to find, that is, area A of the heat exchanger is to be found out. First find the C minimum, that is m dot h into CPH is equal to 210 power 3 divided by 3600 into 1.045, that is m dot h CPH is equal to 58.06 kilowatt per Kelvin. Okay, and m dot C into CPC is equal to the 110 raised to 3 divided by 3600 into 116.3 kilowatt, 116.3. That is m dot C into CPC is equal to 116.3 kilowatt per Kelvin. Okay. From these two values, find out which one is the minimum value. Okay. From these two values, C minimum is equal to m dot h into CPH, that is equal to 58.06 kilowatt per Kelvin. That is the C minimum. Therefore, obviously, C max is equal to m dot C into CPC, that is equal to 116.3. C max is equal to m dot C into CPC, that is equal to 116.3 kilowatt per Kelvin. Then, so we found out C minimum and C max value. Okay. Then from HMT data book, page number 152, heat transfer is given by heat transfer Q is equal to epsilon C minimum into capital T1 minus small t1. Substituting the values, therefore epsilon is equal to Q divided by C minimum into T1 minus T1, and then substituting the values, we get 14,000 divided by 58.06 into 400 minus 100. We get epsilon is equal to 0.804. This value of effectiveness epsilon is equal to 0.804. Then find the value of C minimum by C max. C minimum by C max. C minimum by C max is equal to both of the values we know. The C minimum value is 58.06 and C max value is 116.3. C minimum by C max is equal to, while calculating, we get answer as 0.499, that is approximately is equal to 0.5. 0.5. Thus, we got the value for epsilon and the C minimum by C max. Then, from our HMT data book, page number 164, for counterflow, there is a graph, that is for the value of epsilon is equal to 0.8 and C minimum by C max is equal to 0.5. We get the value for NTU as is equal to 2.3. So we get the value for NTU as 2.3. Again, from HMT data book page number 153, there is another equation for NTU, that is NTU is equal to UA by C minimum. On this equation, A is equal to NTU into C minimum divided by U. NTU into C minimum divided by U. Substituting the values, it is area is equal to 2.3 into 58.06 into 10 raised to 3, the whole divided by 85. Therefore, area is equal to 1571 meter square. This is the value for surface area of heat exchanger. Thank you for watching this video. Have a nice day.